Okay, so the operating system is the most important piece of software on a computer. But what really is it? So we've got a couple of vocabularies. We're going to talk about files and file systems, operating systems, and again, I'm going to keep hammering home this idea of an interface. So those are kind of our goals. Define an operating system, kind of look over, review again what the definition of an interface is. Look at some of the roles that the operating system fills and look at some of its key components, and then list a few examples. My goal here is not to make you guys experts in operating systems per se, is just to give you kind of a high level look at what the operating system does on a computer, what its purpose is, what its job is, and what it is. So to that end, what is an operating system? At its core, it's a computer program. There's nothing more, I mean, in some sense, it's nothing more simple than that. It's just a computer program that gets loaded into the memory when you turn it on. When you turn it on, a computer doesn't know how to be a computer, and the operating system kind of does that. The first thing it does is say, hey, all of you wires and bits of metal and silicone and plastic, here's your job, here's your purpose. Like that episode of Rick and Morty where the little robot says, what is my key? What is my purpose? And he says, it's to pass butter. It's this depressed robot. Click in there. Why isn't my thing working? Punk. It's a really big program, though. It's huge. We're talking, I think, millions of lines of code is probably really likely. And its job is, what? The buttons aren't working. I don't know why. Yeah, it's not selecting the right thing. All right, whatever. It tells the computer how to do its job. It tells the computer how to be a computer. And in that job, it kind of fills a number of different roles that you would see kind of split between a bunch of people in a more human-centric setting, but the computer is able to fill all of those roles all at once. So boss, assistant, and referee does these three things. And let's, before we get into those, let's talk again, just kind of hammer home this concept of an interface. An interface is the point where two systems meet and interact with each other. Any system is going to kind of like have its own sort of internal mechanism that does its own thing. But when it meets another system and they interact with each other, that's an interface. So for you interacting with a computer, what are the interfaces? What's the point at which you interact with a computer? We already talked about this a little bit last week. What's one way that you interact with the computer?
Keyboard.
Keyboard, a mouse. How do you get stuff out of the computer, like information?
Read it.
Yeah, you read it off of the screen. I mean, if you're blind, you don't. You would use a screen reader of some sort. So, like, those things, all of those devices form the human-computer interface. So then there's other parts of the computer that interface with each other via whatever mechanism. You have interfaces where like entire countries interface with each other via like diplomatic channels. Like you have diplomats that talk to each other and negotiate treaties and trade deals and things like that. Heads of state will call each other on the phone using a technological interface, but still it's an interface between the two systems, which are their executive branches of those countries. This even happens in nature, like different animals, like there's an interface between like the shoreline of a lake is an interface between land and water, and those two systems are interacting at that point. So anywhere that two systems interact is called an interface, or can be called an interface. And there's lots of interfaces in an operating system. But let's look at these three roles that it fills. So as the boss of the system, the operating system lays out all the ground rules. It is it reigns supreme. It is the it's sort of like the supreme dictator of the computer. Nothing happens without the operating system say so. It establishes boundaries for all the other software and devices. It says, okay, you want to load this word processor. This is where you can live in main memory. This is where you can connect to the network. This is no other app can occupy the same place. And there are clear divisions and boundaries. And actually, they've gone to great lengths lately to ensure that every app runs in kind of its own little box. They call it sandboxing because it prevents other apps from interfering with each other. And that's a security measure. It's about preventing viruses from infecting your system and doing terrible things. So an app needs permission from the OS to do anything useful or interesting. But an app wouldn't be useful or interesting if it didn't actually give permission on occasion to do those things. So the operating system is also kind of like the assistant. Each app has to ask the OS for resources, but the OS needs to actually supply those resources that are needed in order for that app to work correctly. So if I need to run my word processor, it needs to exist in memory. If I want to surf the internet on a web browser, it needs to be able to access the network controller. So the operating system's job is to give it access to that. Video games need access to the graphics card. These are all examples of applications that want to do something on a computer, and so they have to ask the operating system first for permission or even like directions on how to get there. And it does that via a system of interfaces, system calls and system function calls. Like here, I'm asking the operating system to, using the operating system's interface to load up some 3D models into the graphics card so that we can render them on the screen. That kind of thing. So that we can, all those great bloody gore effects that you get in some video games, explosions and things like that. That's all a carefully orchestrated dance that's performed by the app and the operating system interacting with each other. The OS is also kind of like the referee of the computer. A computer is expected to be sort of this multitasking experience these days. We want to be able to run multiple apps at the same time. I want to be able to copy and paste something from one app into another app. And if I can't do that, then it's not a very useful experience anymore. Like we don't have just single app. We don't have a single app facing the user at any given time anymore. That's not how it works. Problem with this is a CPU is actually only capable of doing one thing at a time. I mean, you have multi-threaded computers and multi-core computers and stuff, so technically it's more like 4, 6, or 8 things at a time. But for simplicity's sake, we think of it this way. A CPU can do one thing at a time, and so only one app can be running at any given time. So how do we get around this bottleneck? What happens is every few milliseconds, and we're talking like thousandths of a second, like tiny, tiny increments of time, the OS is switching which app gets priority, which app gets to talk to the CPU, which app gets to talk to the graphics card, which app gets to talk to the network controller. And it schedules them in like millisecond increments, like really tiny increments of time. So for the most part, it feels like all of your apps are running constantly. Like there's no interruption. Like you see the video on the screen, I'm seeing you guys kind of move and shift around on these screens, and it doesn't look like you're freezing every few milliseconds, but you are. And so the OS is what schedules all those apps and makes sure that they each get a turn to do their things that they're supposed to be doing. And it makes sure that they all play nice. So every now and again, an app is going to do something horrible, and some error is going to occur, and that app is going to crash. And it's increasingly the OS's job to make sure that that app doesn't crash the whole system. We do not want our entire computer to go ballistic. I mean, occasionally it still does, but we don't want our entire computer to go down just because one app decided to be persnickety. Let's see. Yeah, so when an app crashes, we want it to do so in a way that doesn't corrupt data or crash the whole system, or worse, like there's actually viruses out there that can cause your system to fry itself. It's not just it's not just like corrupting data. It can be way worse sometimes. So these two things are actually kind of linked together to a pretty great extent, because making sure that apps can crash and making sure that apps live in their own little sandboxes that can just be collapsed at will is also linked to security. Like being able to make sure that we can isolate, and making sure the operating system can isolate some sort of nefarious program, like somebody wrote a program that deliberately tries to crash your system. The operating system's job is to make sure that it can't. And so it's just a never-ending arms race, of course. People are still writing viruses that are still capable of destroying your system, but I shouldn't say viruses, I should say malware, because virus is very specific. But you know, this arms race between computer operating system designers and programmers, and then people who are trying to write malware to steal your data or whatever, or encrypt your hard drive and then charge a ransom like they did to the LLBO server. They never did pay the ransom, did they? They just called it a wash and built a new system. Did you ever hear about this happening? I mean, it was last year, like maybe, it must have been in like January or February, I think. I remember a buddy of mine who works for LLBO, and he posted on Facebook that this was like in January, and it's a joke that did not age well. He said, "I think that the server just got the coronavirus." It's just, yeah. Anyway, next. So the operating system is kind of a modular piece of software. This part of this slide, I'm just going to kind of run through, because it's not. You don't need to memorize all these terms, but I do want you to kind of be in some way aware that an OS is actually built of multiple components that all interface and talk with each other. At the very bottom is a special program called the kernel. And this is something we never see or interact with ourselves. It is the core programming of the OS that handles memory management and resource management and the network controller and all that stuff. And this is the kernel is the ultimate authority on who gets to do what. On top of the kernel is an interface for program execution. So if I want to run a word processor or program a word processor, I have access to a series of system calls that I can say, hey, let me write something to the screen. Let me save something to the hard drive or something like that. It also, since technically the resources on a computer are finite, there are only so many gigabytes of memory on a computer, somebody has to manage all of that, and that's the operating system's job. So it has a whole component design around resource management, and largely that's the kernel's responsibility. But like, when you programming an app, you don't have to worry about it. You can pretend like you have unlimited memory, because the operating system's just going to handle it and organize that stuff and direct everybody where they're supposed to go without any problems. The operating system also has to have a way of storing data for a long period of time. So we have a thing called a file system. So we use this metaphor of like a file, literally like a folder with paper inside. That's how we think of it. Like a folder is like a file system is like a filing cabinet full of folders, and inside of each folder are files that could be a Word document or a picture or a music file or some resource or executable for a video game or something. And then also it'll have interfaces that allow you to connect all of your cool devices and things to your computer. So you probably are sitting at some sort of a laptop that more than likely, most of you have a microphone, speakers, a headset maybe you have a camera and on the screen, so that all of these devices, those are not part of the core computer system. Those are all connected to this computer, and the operating system's job is to establish a contract with each of those devices to see how it's going to work, and like negotiating a treaty almost. And it comes in the form of a little tiny computer program called the device driver, and there's hundreds of them all over your computer. One to handle like USB devices, one to handle the things that might be plugged into USB devices, one to handle like the system clock, the network controller, and your graphics card. All that stuff is handled by a series of device drivers. Networking. A computer is useless these days without some sort of networking capability. When I was in like the 5th or 6th grade, we got our first Windows computer, and it did not have a network connection. It was like we didn't have the internet. We didn't know, that wasn't really a thing. It was like the early 90s, maybe late 80s. I think it was the early 90s. And it could not connect to the internet, but that was fine. It wasn't meant to. Nowadays, a device is hardly useful at all if it can't connect to the network in some way, connect to the global computer network that is the internet. Operating system Windows in particular has a whole security suite built in called Windows Defender, and operating systems are more and more responsible for making sure that they're secure. Your Android or iPhone has security stuff built in, like really, really rigid security. Every time you get a new update from Apple or Google or Samsung or whoever, most of those are security updates. Oh, we found a vulnerability. Here's a patch for it. And some of them even have antivirus software built in, like Windows Defender. Oh, the other thing that Apple and Google do to ensure security is by carefully curating all the apps. If you go on, if something actually gets into the Apple App Store, it has been heavily vetted to make sure that it doesn't contain malware. And in the Android the Google Play Store, it's a little different. Anybody can list an app on there, but you can apply to be Play Protect certified, and then Google will vet your software and make sure that it doesn't have any viruses and stuff. And it's a good idea to not install anything that isn't Play Protect certified, because otherwise you can get all sorts of weird crap happening on your phone. They're also responsible for giving you some sort of a user interface. And I'll talk about that in just a little bit. For Windows, it's the desktop. We get this desktop metaphor, and I'll go ahead and hit that right now. That's not a bad idea. Let's turn off my annotate. There we go. So we have, just open up a Word document here real quick because it's a good example. Close that. Okay, so almost all modern operating systems operate using what we call a WIMP interface. Let me get my pen out again. WIMP. So that's window, icon, menu, pointer. So I have Windows, and in Windows, that's these things right here. These things that I can move around. They kind of behave like sheets of paper. I can put one on top of the other. I can say this one's partly covering the Word document. They slide around each other. I even get there's a little shadow that it generates here that shows that this is like on top of the other thing, and it casts a shadow on there. This is all very carefully programmed to give you visual cues that, in fact, we have two windows and one is on top of the other. And it's subtle, but it works really well. Like, it gives you that indication. You can click and drag them around. So everything is contained within a window. There's nothing that spills over onto the desktop except like me drawing on there with Zoom. This is actually a violation of this WIMP contract. Icons, we have icons everywhere, little buttons with colors and some sort of visual indicator of what's going on. I have a whole bunch of them on the bottom here. We even use the same thing in our web browsers. So like Canvas has icons here along the left-hand side here that kind of give you a quick visual cue that there's some of what's in there. We have menus galore. My web browser has a menu here that has a bunch of settings and things like that. Microsoft kind of changed the way they use menus, but I guess you can consider these toolbars to be menus. And then you have a pointer, which is your way of interacting with it all. On a touch screen, your pointer is basically just your finger, but on a desktop or other kind of operating system, you use a mouse or some other touchpad or whatever to interact with all of to move a single pointer thing, little widget around on the screen and interact with those things. And let's delete my annotations. Okay. And bring this back. Come on back. Go away. Display settings. Swap. Okay. So that's all these. We have examples. The main 4 workstation operating systems are Microsoft Windows, Mac OS, and Chrome OS, and they each have their advantages and disadvantages, and I talk about them in the text, so if you want to look at them, I kind of list a few pros and cons of each one, and then of course the family of operating systems that is called Linux. It's actually a collection of different operating systems that are typically free. Windows costs about $100 for a license, but and Mac OS comes with really expensive proprietary hardware. Linux is totally free. You can install it on anything. And there are more, but there's really only 2 mobile OSs that control like 99.9% of the market, and that's Android and iOS. So one's maintained by Google, the other by Apple, and they both have their devotees and their detractors, but I think that largely they're feature equal. They can do pretty much everything. They pretty much have their strengths, they have their weaknesses, but they both accomplish the same goal. Any questions on this? Like anything you've been dying to know all your life about operating systems, at least from the high level perspective? All right. I will, Raina, just stop recording.